Galileo.
And the concept
of inertia.
Perhaps Galileo's greatest contribution to physics was his formulation of the concept of inertia. An object in a state of motion possesses an inertia that causes it to remain in a state of motion unless an external force acts on it. In order to arrive at this conclusion, which will form the cornerstone of Newton's laws of motion, indeed, it will become Newton's first law of motion, Galileo had to abstract from what he and everyone else saw.
Ready? Most objects in a state of motion do not remain in that state of motion. For example, a block of wood pushed at constant speed across a table quickly comes to rest when we stop pushing. Thus, Aristotle held that objects at rest remained at rest unless a force acted on them, but that objects in motion did not remain in motion unless a force acted constantly on them. Galileo, by virtue of a series of experiments, realized that the analysis of Aristotle was incorrect because it failed to account properly for a hidden force, the frictional force between the surface and the object.
Thus, as we push the block of wood across the table, there are two opposing forces that act. The force associated with the push and the force that is associated with the friction and that acts in the opposite direction. Galileo realized that as the frictional forces were decreased, for example, by placing oil on the table, the object would move further and further before stopping. From this, he abstracted a basic form of the law of inertia. If the frictional forces could be reduced to exactly zero, not possible in a realistic experiment, but can be approximated to high precision, an object pushed at constant speed across a frictionless surface of infinite extent will continue at that speed forever after we stop pushing, unless a new force acts on it at a later time.